Hi, this is Ramaseshu, chemistry faculty. Now I'm going to discuss with the topic ionic product of water. How to define ionic product of water? You want to know. Going to share the screen. See here. This topic is in ionic equilibrium. Here I'm going to discuss about ionic product of water. AW. So if you want to know about ionic product of water, first you have to know what is meant by strong electrolyte and what is meant by weak electrolytes. So strong electrolyte nothing but any strong acid and strong base and all salts which are soluble. In what? If you want to take about weak electrolytes, so how can you take weak electrolyte? Weak electrolytes generally called as weak acids, weak bases, and sparingly soluble salts. Yeah. So what is the difference between strong electrolyte and weak electrolyte? A strong electrolyte is nothing but these substances undergo complete dissociation or ionization. For this type of substances, degree of dissociation is alpha, that is equal to 1. That means 100% dissociation takes place. So here 100% dissociation takes place. That is why these substances are said to be strong electrolytes. Nothing but if I take an example HCl, when I drop this HCl into water, how many moles I am dropping? All the HCl molecules are converted into H plus and OH minus ions. That means there exists only irreversible process. In this irreversible process, 100% the complete dissociation of ions takes place. Therefore, if I take 1 mole of HCl, this 1 mole of HCl undergo complete dissociation forms 1 mole of H3O plus and 1 mole of OH minus ions. But there exists no equilibrium here existed because these substances are said to be strong electrolytes. So we can't say the equilibrium between the ions and undissociated molecules. There is no ionic equilibrium. But if you take weak electrolyte, if you take a weak electrolytes are generally partially ionized or partially dissociated. They are partially dissociated. Degree of dissociation, if you want degree of dissociation, alpha is less than 1. Generally, they will undergo less than or equal to 5% of dissociation. Therefore, there exists equilibrium, a dynamic equilibrium which is established. Here, a dynamic equilibrium is established. That dynamic equilibrium is nothing but ionic equilibrium. So, what is the relation of this ionic equilibrium with the ionic product of water? Generally, in the case of weak electrolytes, 100%, there exists ionic equilibrium between undissociated molecules and their ions. If I take example here, CH3COOH is a weak electrolyte or weak acid. When I drop it into water, here I will get a CH3COO minus plus H3O plus ions produced. Nothing but if I take 1 mole of acetic acid, this 1 mole of acetic acid undergo incomplete dissociation. So when there exists incomplete dissociation, what will happen? I can't get 1 mole of acetate ions and 1 mole of H3O plus ions. Here less than 1 mole, here also less than 1 mole. As I said, here 5% dissociation, or if I consider it as a 5% dissociation, if I have 100 molecules of acetic acid, 5 molecules of 5 moles, 5 acetate ions, 5 molecules of acetate ion. Here also 5 molecules of acetate ion will be generated. That means H plus ions will be generated. Sorry. So that means out of 100 particles of acetic acid, only 95 particles are remained. 5 particles are dissociated. Nothing but here 95 molecules are undissociated. So there is undissociated molecules and there is dissociated ions. There develops equilibrium between undissociated molecules and dissociated ions. Such equilibrium is said to be ionic equilibrium. This is ionic equilibrium. So now you know that what is ionic equilibrium. Based on this, I can explain ionic product of water. How can you explain ionic product of water? Kw. If you want to say the ionic product of water, 100% you have to know about the equilibrium condition. So if you take pure water, water is a pure water, pure condition. Pure water is a poor conductor of electricity. Poor conductor of electricity. This pure water is a poor conductor of electricity, therefore it can act as a weak electrolyte. Nothing but there exists incomplete dissociation. Incomplete dissociation. So as I said earlier, incomplete dissociation 100% there exists ionic equilibrium is established. Ionic equilibrium is established in the case of water. Ionic equilibrium 100% it should be dynamic equilibrium only, both forward and backward reactions takes place. So here how the ionic equilibrium is established, here there exists autoprotolysis or self-protonation of water takes place. So if all these, if I want to explain in the form of a chemical reaction, if I take liquid water, in those water molecules are there. So one water molecule can act as a Bronsted acid. One water molecule can act as a Bronsted base. B means Bronsted acid, Bronsted base. Bronsted acid nothing but H plus ion donor. H plus ion donor is nothing but Bronsted acid. H plus ion acceptor is nothing but Bronsted bases. So here proton is transferred from one H2O molecule to another H2O molecule. Then there develops H3O plus ions in the water and OH minus ions in the water. But the equilibrium is established. Why? Because water here can act as a poor conductor of electricity or weak electrolyte. Then there develops ionic equilibrium. You see why I explained earlier weak electrolyte, strong electrolyte. If I want to know about ionic product of water, 100% what we have to know, must and should have to know about what is ionic equilibrium. Based on the ionic equilibrium, I will connect this concept to law of chemical equilibrium. Then I have to take a derivation or expression for ionic product of water from law of chemical equilibrium or equilibrium constant. So here what will happen here? Whatever the particular water molecules are there, water molecules, if they are pure condition, 100% they can access poor conductor of electricity. Poor conductor nothing but weak electrolyte. There is incomplete dissociation. And what will happen? Ionic equilibrium will be developed. That is dynamic equilibrium only. Both forward and backward reactions takes place. And if you want to get this dynamic equilibrium or ionic equilibrium, 100% there should be autoprotonation takes place. When autoprotonation takes place, one water molecule can give proton, another water molecule can take proton. Therefore, water can access both Bronsted acid and Bronsted base because it has a amphoteric nature. Finally, then autoprotolysis or self-protonation takes place. Due to this self-protonation, there develops equilibrium that is said to be ionic equilibrium in the case of water in pure condition. Now, let us consider this. The above equation I can represent like this. I will take water as aqueous equilibrium. Here H3O plus, I can write it as H plus aqueous, and OH minus ion, I can take it as aqueous. H3O plus, H plus ion in aqueous medium can act as H3O plus, OH minus ion in aqueous OH minus, hydration takes place, there develops ionization constant Ki. So here Ki is nothing but it is an equilibrium constant which is said to be dissociation constant of water like Ka in the case of weak acids, which is directly equal to, according to equilibrium constant or law of chemical equilibrium. What is equilibrium constant expression? Product of concentration of the products by product of concentration of the reactants. Here reactant is what? Water. Products what? H plus ions and OH minus ions. We have two steps I can write, but here I am going to write only single step. Ki is the dissociation constant. Then I will multiply Ki with the concentration of H2O, which is equal to H plus ions concentration and OH minus ions concentration. Here, concentration of H2O is 55.5, that is directly equal to molarity of water. So it will be fixed value. Why? Because water molecules are very, very less amounts only dissociated. Therefore, this Ki into concentration of H2O, I can consider it as another constant which is said to be ionic product of water. That is directly equal to H plus ions concentration and OH minus ions concentration products. So ionic product of water is nothing but what? A product of H plus ions and OH minus ions. So ionic product of water, ionic product of water, Kw is product of H plus and OH minus ions at a given temperature. This is a constant value we'll get at a given temperature. If I take H plus ions concentration and OH minus ions concentration in water, then the product of H plus and OH minus ions concentration in water is said to be ionic product of water. So what are the applications we can get by the use of this equation? Let us consider, if you want to know the applications, first you have to know about ionic product of water. Ionic product of water, you know that Kw, which is equal to concentration of the H plus ions into concentration of OH minus ions, that is nothing but ionic product of water. With respect to the dissociation constant, how can we write? I can write Kw is equal to Ki into concentration of H2O, that is Ki into molarity of water, that is equal to Ki into 55.5, which is directly equal to product of H plus ions concentration and OH minus ions concentration. From this, I can write Ki. If I want to find out K, how to get K value, then I can write the formula Kw by molarity of water. So molarity of water is fixed, that is 55.5 molar. Then Kw by 55.5 is nothing but Ki. So since Ki value depends on Kw, that means as the Kw value changes, Ka value changes. So when Kw value change, that means here Kw is directly proportional to temperature. That means if you want to find out Ki, 100% you have to know about Kw. Kw is directly proportional to temperature. That means Kw depends on the temperature. Kw depends on the temperature. So KW is KW value. If I take KW value fixed at a given temperature. Different at a different temperatures. This its value is different at a different temperatures. Let us consider at 25 degrees centigrade. At 25 degrees centigrade, Kw is a fixed value that is about minus 10 power minus, sorry, 10 power minus 14 mole per liter whole square. So 25 degrees centigrade, this value is fixed. This is a constant value at 25 degrees centigrade. There is no change in the Kw value. Kw value is fixed. If temperature is greater than that of 25 degrees centigrade, if temperature is greater than that of 25 degrees centigrade, what will happen? Kw value, then Kw value is greater than that of 10 power minus 14. I can write molarity whole square also. Why? Why temperature is greater than 25? Nothing but as the temperature increases, dissociation of water increases. So why dissociation of water increases? Let us consider if I have water molecule aqueous condition. Here H plus ions aqueous, here OH minus ions aqueous. What will happen here? I'm writing dissociation constant. So this particular process, let us consider H plus ions and OH minus ions. We are getting here delta H is positive. This process is endothermic. So as the temperature increases, what will happen? As the temperature increases, dissociation of water increases. When dissociation of water increases, H plus ions concentration increases and OH minus ions concentration increases. And finally, Kw value increase. Here we have to apply Le-Chatelier principle. We have to apply Le-Chatelier principle. As per the Le-Chatelier principle, the equilibrium shifts towards forward direction if you increase the temperature. If you increase the temperature, the equilibrium shifts towards forward direction. Therefore, H plus ions concentration increases as well as OH minus ions concentration increases. When H plus ions concentration and OH minus ions concentration increase, automatically what will happen? Product of H plus and OH minus ions increase. When product of H plus and OH minus ions increases, then Kw value increases. That is why as the temperature increases, dissociation of water increases. When dissociation of water increases, the H plus ions concentration and OH minus ions concentration increases. Finally, Kw value increases. In the same way, if I take a low temperature, let us take, if the temperature is less than that of 25 degrees centigrade, then Kw value is less than that of 10 power minus 14 mole per liter whole square. Similar phenomenon is same. Temperature decreases, dissociation decreases, H plus ions concentration decreases, OH minus ions concentration decreases, Kw value decreases. Kw decreases. Remember this point. That is why whenever we are going to do different calculations with respect to Kw, if you want to find out H plus or OH minus ions, must and should we have to know about Kw at a given temperature. At a given temperature, Kw value is fixed, but as the temperature changes, 100% Kw changes. When Kw changes 100%, what will happen? There is a deviations in the H plus ions and OH minus ions concentration whenever we are going to do different calculations related to ionic product of water. So what I said up to now, applications, you see here, applications I started, first you have to know about ionic product of water. That ionic product of water is nothing but H plus ions into OH minus ions concentration. Kw is nothing but a dissociation constant into molarity of water, that is 55.5, already we discussed. And Ki is nothing but Kw by molarity of water. Dissociation constant of water is nothing but Kw by 55.5. So if you want to find out K, 100% you have to know about Kw. If you want to know about Kw, 100% at what temperature the water is present. Therefore, Kw depends on the temperature. At a given temperature, Kw is fixed. At different temperatures, Kw will be varied. At 25 degrees centigrade, we know that Kw is a fixed value, that is about 10 to the power of minus 14 moles per liter whole power 2 or whole square. This is constant value at 25 degrees centigrade. If temperature is greater than 25, Kw is greater than 10 power minus 14. Why? Because dissociation of water takes place. When dissociation of water increases, automatically H plus ions concentration and OH minus ions concentration increases. When H plus and OH minus ions concentration increases, dissociation constant increases, Kw value increases. Now you see, as the temperature decreases, less than 25 degrees centigrade, automatically Kw is less than that of 10 to the power of minus 14. We have a question, there may be chance to give like this. At 90 degrees centigrade, what is the value of Kw if Kw at 25 degrees centigrade is 10 to the power of minus 14 mole per liter whole square. Option 1, 10 power minus 15 molarity whole square. Option 2, 10 power minus 16 molarity whole square. Option 3, 10 power minus 14 molarity whole square. Option 4, 10 power minus 12 molarity whole square. So here it is a theoretical value. We can say say the theoretical data. Just wait. Some issue is there. Net. Choose one. Okay. Charging issue is there. So here, what I can write here at 90 degrees centigrade, the value of Kw, if I want to find out, we know that temperature increases, Kw value increases. Therefore, at 90 degrees centigrade, Kw should be greater than that of 10 to the power of minus 12 molarity whole square. Sorry, 10 power minus 14 molarity whole square. So here you see 10 power minus 15 lower value, equal value. Fourth option is it is greater than that of 10 to the power of minus 14. Therefore, the answer is 10 to the power of minus 12 molarity whole square. This is one application we have to know. Based on the temperature, if I want to find out, I can take like this. Now I'm going to take two cases. Generally, they will ask in the case of problems related to ionic product of water. Case 1. In pure water, how can you give a relationship between H plus ions and OH minus ions with Kw? In pure water, if I take always H plus ions concentration is equal to OH minus ions concentration. Always. Therefore, if I want to give a relationship between H plus ions with OH minus ions with respect to Kw, what I can write? H plus ions concentration, which is equal to OH minus ions concentration, that is directly equal to Kw. I can write like this, Kw. So here, what I can write? Kw under root 100%. What here we have to consider? If I want to consider 100%, we have to know about the condition is pure water or not. In pure water, always H plus ions concentration is equal to OH minus ions concentration. If you want a question based on this, at 90 degrees centigrade, Kw of water is 10 power minus 12 molarity whole square. Then find out H plus ions concentration and OH minus ions concentration in pure water. I have a question like this. So then directly what I can do, the condition is pure water condition. Therefore, H plus ions concentration always is equal to what? OH minus ions concentration, that is directly equal to square root of 10 to the power of minus 12. Therefore, that should be 10 to the power of minus 6 moles per liter. This is your answer. Is it neutral or not? Yes. Water is neutral. What is a neutral condition? So beyond this level, if you go, you will get pH concept. pH is a 6 for neutral condition here. And pOH is also 6 for neutral condition. So what is pH and what is pOH? We'll discuss after this concept. So before that, I'm giving a particular clarity that we can't say always pH is equal to 7 is a neutral condition. pH is 6 also neutral condition, that depends upon the Kw value, and that Kw value depends on the temperature. That is why don't think if anybody asked about pH is equal to 7 is a neutral condition, that is wrong. At a given temperature, based on the Kw value, if H plus ions concentration is equal to H minus ions concentration, then I can say that the particular solution should be neutral based on H plus ions and OH minus ions concentration and Kw value. So here case is in pure water, if I want to find out H plus ions concentration, 100% we have to take the formula that H plus ions concentration is equal to OH minus ions concentration. That is directly equal to root Kw. This is only the formula we have to use to find out H plus ions and OH minus ions concentration in the case of pure water. Another case, if I take case 2, in a solution, how to give relationship between H plus ions and OH minus ions concentration. In a given solution, H plus ions concentration may or may not be same. But the product of H plus and OH minus ions concentration should be equal to Kw at a given temperature. Product Kw is fixed. Kw at a given temperature is constant. But H plus ions may be equal or may not be equal to here may or may not be equals to OH minus ions. Let us consider. Therefore, if I want to find out H plus ions concentration, then what I have to do at that particular temperature, if you know OH minus ions, I will use formula H plus ions concentration is equal to Kw by OH minus ions. Or if you know H plus ions concentration, if you want to find out OH minus ions concentration, OH minus ions concentration is equal to Kw by H plus ions concentration. That means here I can't say directly H plus ions concentration is equal to OH minus ions concentration, that is directly equal to square root of Kw. Here I can't say. So if I take a question at 25 degrees centigrade, if H plus ions concentration in a given solution, it may be acidic or basic, I don't know, 10 to the power of minus 6 molar, then find out OH minus ions concentration, if anybody asked it like this. So here, how can you say the OH minus ions concentration? OH minus ions concentration into H plus ions concentration is equal to Kw. We know that ionic product of water formula, H plus into OH minus ions concentration is equal to Kw. Then OH minus ions concentration is equal to what? Kw by H plus ions concentration. That is equal to 10 power minus 14. This value we know. At 25 degrees centigrade, Kw is fixed. Given H plus ions concentration as 10 power minus 6. Then 10 to the power of minus 14 plus 6. Then OH minus ions concentration is equal to 10 to the power of minus 8 molar. So this is 10 to the power of minus 8 molar. So if it is 10 to the power of minus 8 molar, what I have to do? Whether if they are asking question, either the solution is basic or acidic, 100% you have to know that H plus ions concentration is equal to 10 power minus 6 and OH minus ions concentration is equal to 10 to the power of minus 8. Therefore, from this I can say that H plus ions concentration is greater than that of OH minus ions concentration. Therefore, the solution is an acidic solution. It is an acidic solution. So what are the conditions for acidic solution, basic solution? If you want to say, I will put note and write that if H plus ions concentration greater than that of OH minus ions concentration, the solution is acidic solution. If H plus ions concentration is less than that of OH minus ions concentration, the solution is basic solution. If H plus ions concentration is equal to OH minus ions concentration, the solution is a neutral solution. So according to the data what I gave, the solution is a neutral solution or basic solution or acidic solution if you want to know. 100% we have to know this condition. Already here I mentioned. Here what I got H plus ions concentration and OH minus ions concentration relationship is H plus greater than that of OH minus. Therefore, the solution becomes S. So this is about ionic product of water and different applications. So here, if you want to know about ionic product of water and its applications, 100% what we have to know from the beginning, I told. First, you have to know about strong electrolyte, weak electrolytes. After that, if you know weak electrolyte, 100% they develops equilibrium constant. Whenever there is equilibrium constant, based on the equilibrium constant, I can say ionic product of water using equilibrium constant. Finally, I'm getting a Kw expression. That Kw expression is nothing but ionic product of water. That ionic product of water is nothing but Kw is equal to H plus ions concentration into OH minus ions concentration. So how we can apply this formula to calculate different questions? 100% if you want to know about that ionic product of water, we have to know the formula, then formula for ionization constant, then Kw depends on temperature, and finally based on the temperature how Kw value varies. Based on that we have a different questions, and then main two conditions are in pure water, what will happen, and in the case of solution, how to find out H plus ions and OH minus ions. In the case of pure water, H plus ions concentration, OH minus ions concentration should be equal. That is directly equal to root Kw. That Kw value depends on the temperature. In the case of solution, H plus ions may or may not be equal to OH minus ions. Therefore, 100% if you want to find out H plus ions concentration, we have to use Kw by OH minus ions concentration to find out H plus. We have to use Kw by H plus ions concentration to find out OH minus ions. Based on that, I gave one question to you. Here, that is a question. So I got OH minus ions concentration 10 to the power of minus 8, H plus ions concentration given as 10 to the power minus 6. When H plus ions concentration is greater than that of OH minus ions concentration, automatically the solution is said to be acidic solution. Then finally, we got acidic solution, basic solution, and neutral solution. 100% that depends on the H plus and OH minus ions concentration at a given temperature. So H plus is equal to OH minus, H plus less than OH minus, H plus greater than OH minus ions, H plus greater than OH minus ion acidic solution, H plus less than OH minus ion basic solution, H plus is equal to OH minus ions concentration. Then finally the solution is said to be neutral. And I will stop my class by taking one question at 25 degrees centigrade. Find out number of H plus ions. Find out number of H plus ions present in pure water. In the case of pure water, what they are asking, find out number of H plus ions present in pure water. How to solve this question? I will explain and I will stop this class. If you want to find out H plus ions, number of H plus ions, I am not asking about number of moles of H plus ions. Here, number of H plus ions I am asking. So first at a 25 degrees centigrade, the condition is a pure water condition. There is a pure water. In that pure water, H plus ions concentration is equal to square root of Kw, that is directly equal to OH minus ions concentration. Pure water is always neutral. Why? Because H plus ions concentration is equal to OH minus ions concentration. Therefore, H plus ions concentration is equal to square root of 10 to the power of minus 14 molar. that is equal to 10 power minus 7 molar. Why? Since at 25 degrees centigrade, Kw is equal to 10 power minus 14 molarity whole square. Therefore, H plus ions concentration at 25 degrees centigrade is 10 power minus 7 moles per liter. Therefore, at 25 degrees centigrade, H plus ions concentration is 10 to the power of minus 7 moles in 1000 ml of water. That means 10 power minus 7 into Avogadro number of H plus ions in 1000 ml of water. So simply how many H plus ions are there at 25 degrees centigrade? 10 power minus 7 into Avogadro number, nothing but 6 into 10 to the power of 23 into 10 power minus 7 H plus ions in 1000 ml water. That is 6 into 10 power 16 H plus ions in 1000 ml of water. If I change this question, find out number of H plus ions present in 1 ml of pure water. 1 ml of pure water. Here I am changing the question. 1 ml of pure water at 25 degrees centigrade. Here I am asking 1 ml. 1 ml, if anybody asked, 1000 ml of pure water that contains 6. Generally, I'm writing 6.023 into 10 power 23. If you want, you can write like that. 6.023. Avogadro number nothing but 6.023 into 10 power 23 into 10 power minus 7. Here also 6.023 into 10 power 23 minus 7 nothing but 16. 16, 23 minus 7, 16. H plus ions in 1000 ml. Therefore, here I am writing 6.023 into 10 power 16 H plus ions. If you want 1 ml, 1 ml of pure water, then how many H plus ions are there? The number of H plus ions present in 1 ml of pure water, which is equal to 6.023 into 10 power 16 into 1 by how much? 1000 I can write. Therefore, the answer is number of H plus ions in 1 ml of pure water is 6.023 into 10 to the power of 13 H plus ions present in 1 ml. So like this, different questions there will there may be chance to ask about ionic product of water. So this is the particular concept and different model problems there may be chance to ask. So I think everybody understood about this topic, KW, ionic product of water and its applications. So thank you for listening. And if any particular conceptual doubts are there, we have to read all the points from the beginning. So here I started ionic product of water directly instead of saying strong electrolytes and weak electrolytes. That is why I started with the strong electrolytes and weak electrolytes. Okay. Thank you. Thank you. I'm going to stop this class. Thank you.